Hey mathematicians, we're going to do a quick refresher on what factoring expressions looks like. As a reminder, it is just like doing distributive property, only instead of multiplying everything by the same number, we're going to divide everything by the same number. So let's look at number 1, 6x plus 9. The first thing I notice is my first term has an x and my second term does not. So I'm going to focus on the 6, my coefficient of 6, and my constant of 9. So let's think about what those two terms have in common. I know my factors of 6 are 1, 2, 3, and 6. And my factors of 9 are 1, 3, and 9. And I want to factor out or divide out the biggest term possible. So looking at these two lists, I see 3 and 3. Anything beyond that, they're not in common. 1 doesn't really help us because it doesn't change anything. So I'm going to take both of these terms and divide by 3. Now, I want to rewrite my expression so it still has the exact same value as the original expression. So I'm going to take a set of parentheses and take that 3 that I'm factoring out and just stick it outside there. That means that the 3 would get multiplied by what's inside. 6x divided by 3 is 2x. And positive 9 divided by 3 is positive 3. And I can double check my work by using the distributive property. I can do 3 times 2x and 3 times 3 to see if I get back to the exact same expression, and I do. So now let's look at number 2. I've got a negative 20y and minus 5z. So first thing I notice, my variables. I've got a y, I've got a z. They're not the same, so I can't factor that out. However, I do have a negative 20 and a negative 5. What that means is I'm going to have a positive factor and a negative factor for both of them. So let's start with negative. Let's start with negative 5. It's got fewer. That is divisible by 1 and 5. Done. Well, 20 has a lot more factors, or negative 20 rather. It's divisible by 1, 2, 4, 5, 10, and lastly 20. So again, I want to find the largest number that is in both lists, and it's obviously going to be 5. Whenever you have a prime number, that's really nice. I'm also going to go ahead and factor that negative out, so I'm going to divide both by negative 5. It's always nice when you can divide the negative out and be left with positives inside your parentheses whenever possible. So again, I'm going to set up my parentheses. I know I'm going to have something inside the parentheses, and whatever I'm dividing by goes outside the parentheses, so negative 5. I've got a negative 20y divided by negative 5. I know a negative divided by a negative is a positive, so I can really just focus on 20y divided by 5. 20 divided by 5 is 4, so 20y divided by 5 is going to be 4y. And then I've got a negative 5z divided by negative 5. Well, anything divided by itself is 1, so I can call this plus 1z or just z, because z and 1z are the same thing. We can also do the same factoring when it comes down to expressions with multiple terms. So let's look at number 10. I've got 40b minus 80c minus 40d. Immediately I'm noticing I've got variables in all three, b, c, and d, but none of them are in common, so I'm not going to factor out any of the variables. However, I can factor out a term from these coefficients, 40 and 80. And I think it's pretty easy to see what I could factor out. But if you weren't sure, you could always list all the factors of 40 and all the factors of 80. However, I can tell 40 is a factor of 80, so I can divide 40 out of all of these terms. Well, that was fun. I didn't mean to save that. So I'm going to divide by 40, divide by 40, and divide by 40. And just like we did up here, we got to set up some parentheses, and whatever we're dividing out or factoring out goes outside the parentheses. So since I'm dividing 40 out, I'll stick it outside the parentheses. And now I've got to start my division. 40b divided by 40. Well, 40 divided by 40 is 1. That simplifies, and I'm left with just b. You could also write 1b. There's nothing wrong with that. Minus 80c divided by 40. Well, 80 divided by 40 is 2, and it's a subtraction, so minus 2c. And then last I've got minus 40d divided by 40. I know 40 over 40 will simplify to 1, so minus, I could write 1d or just the variable d. And if I wanted to double check it, make sure that I'm correct, all I would have to do is use the distributive property to go back and multiply it out. If I can multiply it and get back to my original expression, I know I've done it correctly. It doesn't matter whether you've got a variable in the first term, or a variable in both of the terms, or a variable in the second term. As long as you keep that variable attached where it needs to be, you're set. So for 8, I could factor a 7 out of both of those. And when I divide 42 by 7, I get plain old 6. And when I do 35 divided by 7, I would get 5, but that 35 has the w attached, so it's just 5w. I can always check my work by distributing that 7 and making sure that it gets back to my original expression.